Hi, today we are going to talk about something called the chain rule. So when we differentiate function that is actually composition of two or more other functions, we use chain rule. This is how it works. So this is f of g of x, and we're trying to find its derivative. So it's going to be the derivative of f with respect to g times the derivative of g with respect to x. This is what it looks like. Let's take a look at this example. So our f of x is sine 2x, and we're trying to find the derivative here. Now we know the derivative of sine x, but that's derivative of sine 2x. So what do we have here? We have our inside function, which is 2x, and our outside function is sine x. So in this case, sine x is what we are going to differentiate first, and we're going to differentiate sine x with respect to x, which basically we ignore what's inside and we just simply differentiate sine. So here's how we are going to do it. So that means f prime of x is going to be the derivative of sine is cosine of 2x. Then times we are going to differentiate our inside function second. We're going to take the derivative of 2x with respect to x, and the derivative of 2x with respect to x is 2. And we get 2 cosine 2x. Let me run through this again, because it's a relatively easy problem, and I want to make sure that we understand it. So we have our function, which is sine 2x. According to this rule, it tells us we want to differentiate our outside function first. That's what f represents. Remember, if you want to put the composition of f of g, g goes inside of f. So in our case, 2x goes inside of sine, right? And we differentiate the outside function first, which happens to be sine, and then we differentiate the inside function after that, which is 2x. And the derivative of sine is cosine of 2x. Whatever you use here, it's the same thing. And then you take the derivative of 2x, which gives you 2, and we have our answer. Okay? Another way to look at that, let me just explain to you. If we go back to this example here, and if we ignore that we call this function f of x, just think about this. We can say that g of x, in our case, is 2x, and f of g is a sine of g of x, right? So when you try to take the derivative, so then f prime of g of x is cosine of g of x, and g prime of x is 2. And of course g of x is 2x, and we are getting the same answer. Let's take a look at another example. Consider this function f of x equals 2x minus 1 to the 5th power. Find f prime of 1. So we actually have to find numerical derivative here. We need to find first the derivative, then we can substitute 1 where we should already know that. Okay, so what do we have here? We have 2x minus 1 first, and then that is raised to the 5th power. So 5th power is our outside function. So we have a power function. Inside of the power function we have another function, which is 2x minus 1. So this is our inside function, and the power function x, something to the 5th power, is our outside function. So how do we take the derivative? We know how to find derivative of power functions. So f prime of x is going to be, to find the derivative of a power function, the 5 is going to go in front. We're keeping what we have, that's not going to change, and we drop the power by 1, which is going to give us 4th power. Times, now we have to find the derivative of 2x minus 1, which is 2. Again, this whole idea with inside versus outside function, you always differentiate the outside function first, and you differentiate the inside function. So the outside function is the 5th power, the power function, and the inside function is 2x minus 1. And after that we simplify that, so that gives us 10 times 2x minus 1 to the 4th. And we do need to find f prime of 1, so we actually need to plug in 1 into this. So it's going to be 10 times 2 times 1 minus 1 to the 4th power, which this whole thing is 1 to the 4th power. The answer here is 10. Okay, next problem. We're trying to find the derivative of sine x cubed. So inside versus outside function, we take x cubed first. And another way, by the way, you can think about this, which one is inside, which one is outside, is if you are given the power of x, if you follow the proper order of operations, what do you perform first? If I give you a power of, a value of x, for this function you are going to do x cubed first. That is going to be your inside function. After you do that, you're going to calculate the sine of that number, and that's going to be your outside function. So our inside function here is x cubed. And according to what we've learned already, we are differentiating sine first. So the derivative of sine function, and you rewrite that, d over dx sine x cubed, is going to be, so the derivative of sine is cosine of x cubed times, and now we need to find the derivative of x cubed, and the derivative of x cubed is 3x squared. And our derivative is going to be 3x squared cosine x cubed. Okay, again, we always differentiate the outside function first, and then we differentiate the inside function. You just have to remember to do both. It's actually the most common mistake, students forgetting that you have a composition of two functions and you have to differentiate both. Moving on. Find the derivative of ln x squared plus 1. Let's think about this. If you're trying to follow the order of operations, you're going to plug in x in here. So you're going to do x squared plus 1 first, then you're going to do ln. That means that we are going to have x squared plus 1 as the inside function, and that means the outside function, ln, is going to be differentiated first. So that means that we are going to get here, the derivative of ln is 1 over that quantity, so x squared plus 1, times, we need to differentiate x squared plus 1, and the derivative of x squared plus 1 is 2x. And we can write the whole thing as 2x over x squared plus 1. Okay, I hope you remember just a couple problems ago we did a sine x cubed. Now we have sine squared x. You have to be very careful here because you need to understand which function is inside, which one is outside. Trigonometric functions are the only functions, well, you probably know by now, where you can square it in this weird way by putting a square to the function and then putting the argument after that. So we need to rewrite that to make sure we correctly understand the setup here. What we have here is sine x squared, and we're trying to do d over dx here. What that means is, if you are looking at this very carefully, you should realize that sine x is the inside function here, and then the square is going to be our outside function. So when we differentiate this, we are going to write, we're going to take the derivative of the power function first, which is 2 times sine x to the first power, so just 2 times sine x, and then you have to take the derivative of sine x, which is cosine x. And this is going to be this problem. Okay. Sine of square root of x. Well, I don't know if you know this, but if you ever need to take the derivative of square root of x, I don't know if you watch any of my other videos, but the derivative here, I always tell students to memorize this shortcut. This will help you save time doing problems. You can actually figure it out. All you do is write square root of x as x to the power 1/2 and then differentiate it from there. But this shortcut is very helpful. It's not really any of the formulas, but it's helpful. So we're doing sine of square root of x. So what do you think the inside function is? Correct? It is square root of x. That means we differentiate sine first, and then we take the derivative of square root. So the derivative of sine is going to be cosine of square root of x times the derivative of square root of x is, as I already mentioned, is 1 over 2 square root of x. And we usually put everything in front of the trig function, so 1 over 2 square root of x times cosine square root of x. Example 7. Differentiate e to the power 2x plus 4. So it's an exponential function with the power 2x plus 4. If you follow the order of operations, you do 2x plus 4 first, then you do e to that power. So this is our inside function, which means we differentiate e to the power first. So when you differentiate e to the power, you are going to, well, e to the power is e to that power, right? E to the x is e to the x when you differentiate that. So it's going to be e to the power 2x plus 4 times, and now we need to take the derivative of 2x plus 4, that is 2. And our answer is 2e to the power 2x plus 4. Okay. Okay, so applications, find the slope of tangent lines of given functions. We should know that the slope of a tangent line is going to be the derivative of the function at that particular point. So that's all we need to do. So essentially we are in need to find f prime of x here. And what do we have here? We have a square root of x cubed minus 2x. And by the way, I hope the shortcut from the previous page is going to help you. Our inside function here is the radicand, because we are going to do that first, and we're going to do the square root. So we're going to have to find the derivative of the square root first. The derivative of the square root, according to the shortcut that I showed you, is 1 over 2 times the square root of whatever you have. We're just going to copy that, times, and now we find the derivative of the radicand of the inside function, which is 3x squared minus 2. And we're just going to write it in a more better looking form, and I think this will do just that. But that's not the answer here. This is just the derivative. Remember, we're finding the slope of the tangent line, so we need to substitute 2 into the function. So f prime of 2 is going to be 3 times 2 squared minus 2 divided by 2 times x cubed. That's going to, so 2 cubed minus 2 times 2. So that is going to give us, what are we getting here? That's 3 times 4, 12. 12 minus 2 is 10, divided by 2 times, this is 8 minus 4. So it's 4, square root of 4 is 2. So we have 10 over 4, or 5 halves. This is going to be the final answer to this problem. Example 9. Find the slope of the line tangent to this function. So we have ln x squared. So our inside function here is ln x, and afterwards it gets squared. That means we differentiate the outside function, the square, first. And when you find f prime of x, you're going to do the derivative of the quadratic function is 2 times ln x to the first power times the derivative of ln x, which is 1 over x. Right? Derivative of the outside function is 2 times ln x, derivative of ln x, which is the inside function, is 1 over x. So we can write that as 2 ln x over x. To find the slope of the tangent line, you find the f prime of x, f prime of 2, and that's going to be 2 ln 2 divided by 2, and we can simplify that, which is going to be ln 2. It's an irrational number, but it's a number. Okay, and I think this is one last thing here. Can we apply chain rule to a composition when you have more complex functions? You know, because obviously you can have a composition of more than 2 functions. So yes, absolutely. You just have to do the same thing. You start your way outside and work your way inside. What we need to do here is break it down into the sequence. So what's the first operation if we go with the order of operation? It's going to be x squared. What's the second operation? It's going to be e to the x squared. What's the third operation? It's going to be sine e to the x squared, correct? If you need to do this with a specific value. So when you apply differentiation to something like that, it doesn't matter how many functions you're going to have. I hope you noticed we were working backwards. So the order of operation tells us to start inside and work your way out. When you differentiate using chain rule, you start outside and work your way in. That means we're going to find the derivative of sine first. Derivative of sine is cosine e to the x squared. Just whatever you have there, you copy that. Times, then you need to take the derivative of e to the x squared, but just e. That's all we worry about. It's e to the power x squared times the derivative of x squared, which is 2x. Let me run through this again. So this is the order. This is the order 1, 2, 3 in which we perform operations here. The arrow is the order in which we are going to apply differentiation here. So we differentiate sine function first, then we differentiate the natural exponential function second, and then we differentiate the power function. We get this expression. All we need to do is write it in some way that it looks makes it look better. So 2x e to the x squared times cosine e to the x squared. And if the function has this one had 3 different functions, you can have 5 different functions. You would do it the same way. I would recommend, if you have a more complex function, to set it up like this, so you can actually break it down as far as what order the operations are performed in, and then you're gonna go backwards to differentiate the function. This is basically how it's done. Okay, hope this helps.